altogether. Okay, there are some fractions, maybe that makes it a bit more complicated. And then I want to look at example 3, and this is going to be really helpful because one of the homework questions is similar. And then what we're going to do after that is we will spend some time reviewing. So you have so many, this last page has, guess what, 25 questions. That's not all the review material. There's more. Okay, do you have to do every single one? Of course not. You can do 0 if you want, right? It's just I'm giving you a lot of stuff to review. So for the rest of the period, you're going to work on these questions, and you've been doing some really good work on the board. So I would encourage you to continue working on the boards. But if you prefer sitting alone and working or sitting with someone and working, you can also do that. So let's finish off this question. So yesterday, we worked on the second way of solving linear quadratic systems. The first way was graphically, where you literally graph the parabola, graph the line. Now, I am curious, did anyone draw a picture as they were solving yesterday? Oh, good. Okay, so what I mean by that is if I had this equation, okay, I would actually, just because I'm pretty graphic, or I'm pretty visual. I think that sounds better. So I would take these two equations and see what they might look like. So for example, if I have this parabola, negative x squared, show me with your hand what it looks like. Yeah, it's upside down. Now, what does the 59 tell you? Liam, that's if it's in the bracket. Yeah. Oh, okay. So that means that at 59, this is what the parabola looks like, right? Approx. Great. Now, notice the vertex is right on the y-axis because there's no horizontal shift. Okay. Then I take this line. I'm like, ugly. But it's not so ugly. Because if you remember, there's a way to find the x-intercept and the y-intercept. So the x-intercept you find by making y equal to 0. So 4x equals 170. Who knows that way? I feel like I'm going to confuse people. So instead, forget that. What I'm going to do is I'm going to rewrite it in slope-intercept form. Divide by 3. 170 divided by 3 is approximately 180 divided by 3, 60. Is that right? I think I need to know the specifics. 170 divided by 3, 57. Okay, so that means the y-intercept of this line is 57. Okay, that's important. And then I see that there's a negative slope. Okay, so a negative slope goes like this. So I can, just by doing a quick graph, I can tell you with some certainty that there will be 2 solutions to this system. Okay, so that when you are solving algebraically, you already know what you're looking for. Does that kind of make sense? Who kind of gets what I just did? Okay, I like doing that because it uses my critical thinking, and then I get to predict what I'm looking for. Well, were we on the right track? Yeah, we were on the right track because we found 2x values, right? So now what do? How do we finish this question off? Don't tell me. Turn to the person next to you and tell them, how are you going to finish this question? Okay, so just a review. We substituted one equation into the other. We used factoring to solve for x1 and x2. Now what? Talk about it. All right. So what do I need to do? Astrid. Yeah, and? So that I do what? So I find the y. Okay, find the y, and then I have my 2 points. All right, so let's start with the first one. Man, is this ugly, right? We have a fraction, and the equation that we have is y equals negative x squared plus 59. Could I have used the other equation? Absolutely. Okay, would it be wiser? Not necessarily. It's going to result in a fraction. All right, so negative x squared plus 59, some fraction practice. 7/3. Oh man, what do I do when I have a fraction and I square it? Okay, try that on your own. Okay, I want everyone to try it. Sebastian, give this a shot. Right, we're all... Where's your note package? Cool. Do you want to take some extra paper and write? Or are you just going to watch and... I don't know. Do what's best for you, right? Do you want to move your desk so that I've got... Yeah. You're welcome. This one? Yeah. Why wouldn't I? No, what did you say? Yes. Into the second equation. Yes. Yes. So I get negative 49/9 plus, oh man, this is ugly. 59. Okay, I need a calculator because 59 times 9. All right. Wow, that's nice. Julian, agree, disagree? Yeah? Okay. So that there was a lot of bedmas in there. So did you get 482/9? Yeah? Good. Okay, if you didn't, what's the question? Right? There's so many places where I might make a little mistake. All right, so that gives us one of the points. Yeah.
Why, when you like for the negative x squared, why does the negative not stay in the bracket?
Great question. Okay. So this is Luke's question. Luke is saying, why don't I put the negative inside the bracket? And this is why. Because it's not like that. Okay. The x is only 7/3, so we're squaring the 7/3. Great question. All right, let's go and find the second one. The second x is -1. Thank goodness. That's easier. Sub x2 equals -1. I'll do the same equation. So try to do this on your own. Finish the question off on your own. Okay, like write the final statement. All right, another bedmas nightmare. It is not 60. What are your questions, folks? I love your questions. Please ask them. Okay. Yes, Timur.
Can we use quadratic formula for this?
Instead of factoring?
Yeah.
Yep.
It won't be a mistake.
No.
The same answer.
Yeah, that's fine.
Okay.
If I were to say, like, on the test, there will be a question that I will say, solve by factoring. And I bolded the factoring. If you do it with quadratic, you don't get full points. You get like half a point. Okay? But otherwise, that's only one question. Every other question you get to choose. Now, if you had to graph these points on a graph, you definitely change it into a decimal, because I don't even know where to draw 482 ninths, right? Like, I would need to change it into a decimal so that I know approximately where to graph it. Are we good here? All right, let's do the next one, because this one is the one that has a different type of solution. So what are we going to do before we even start solving algebraically? What do we do? What do we do? What does your inner Miss Sly say? Yeah, Astrid.
Label equation 1.
Okay, that's good. But that's not what your inner Miss Sly says. What does the inner Miss Sly that likes to jump off desks say? Yes, Greg. Draw a picture. Let's draw a picture. Let's use our critical thinking skills. So I'll start with the parabola probably. Okay. So all I could really say from looking at this is that it's an upside down parabola. What's the vertical shift? It's hard to say. It's hard to say. So I might plug in like, okay, what is the y-intercept? So when x is 0, what is y? Well, it's also 0. Okay. So that might mean my parabola is like something like that. Okay. And then I look at my linear equation and I'm like, okay, it crosses the y-axis at y equals 1, and it has a positive slope. So it's either this one or it's this one, right? So in this case, I would say drawing the picture doesn't give me anything definitive unless I were to actually take more time to graph it. But I'm like, okay, that's kind of a picture for me. Okay, that's all I could say for now. Okay, moving on. So how are we going to solve? Substitute. That's a good idea. Let's go ahead. Let's have everyone solve this. So I'm going to sub equation 1 into equation 2, or 2 into 1. It's the same thing. Or you might say y equals y. All right, so we're just equating the two right sides of the equation. Because we want to find the x's, we want it to be in standard form. So 0 equals everything else. Right, Mustafa? What are we not going to do?
Make one side equal one instant.
Okay, what other concept are we not going to do? Zach, what is the one that we definitely don't want to do? Pardon? Completing the square. Excellent, right? That would be silly, wouldn't it? Like silliness. All right. So 2 things to do. Are we this far? So what do I do here in this case? There are options. What's one way, Luke? I could do the quadratic formula. Absolutely. Yeah, Julian? It's negative 1 or positive. Oh, did I make a mistake? Yeah, it's supposed to be negative. Thank you. Thank you. Okay, so quadratic formula is one answer. What's another way?
I was thinking factoring, but can you make it x squared plus 1 instead?
You can't change the plus. Oh, yeah, you could. Yeah. You could say this. X squared plus 1. Yeah, same. Yeah, I could factor it, but I'm not doing difference of squares. You don't mean x plus 1, x minus 1.
No, I was just saying that, like, could you swap the signs instead of
Yeah, you can, but you can't. This is actually not factorable. Liam, what do I do?
I was gonna say the same thing.
Okay, yeah, this is not factorable. Do not try to do x minus 1, x plus 1. That's a really good mistake. Do you know why this is a really excellent mistake? Why?
Because the signs of plus and minus.
Yeah, if this was a minus, then you could do difference of squares. But we can't because it's not a minus. All right, so instead, quadratic formula is great. It just takes too much time. So Luke, watch this. Okay, why is that better? Because now I can say, oh, what if I just take the square root of both sides? And what must I write? Yeah. Before that, Annabelle. Okay. Plus minus. Because I am taking a square root of an x, I write plus minus. So wait, let me rewrite it here because it got a bit messy. So I had x squared equals negative 1. And then I'm like, okay, no problem. I'll get rid of the squared by taking the square root. As soon as you're taking a square root of an x, you're writing plus or minus. That means we have two answers. What is the square root of negative 1?
1i.
Just I, right? We don't even have to say 1i. Oh, cool. So I can say that x equals positive or negative I. So x1 equals I, and x2 equals negative I. Wow, isn't that fun? Where do I draw that on a graph? You can't, right? Because our axes are real, we can't draw it. So what does that mean? We are looking for points of intersection. What does it mean, Kajik?
No solutions.
That's right, no solutions, no points of intersection. So when we get to a point, and in your homework question, you had a case where there were no solutions, and that is because the discriminant, that wasn't the discriminant. You had an I value. When you have an I value, that means no real solutions and no points of intersection. Okay? So therefore, we can say no real solutions because there are complex solutions, and no points of intersection. Those two graphs do not intersect. This is what it's going to look like. Okay? Questions? Yes. Yes. So, folks, yes, Annabelle.
If this was on a test and the x was imaginary, can we even do the rest of the question?
Oh, good. All right. So, because in your homework, we got to a place of like some people had like 186 over 6, right? So, and I said, reduce it, like simplify this as much as you can. So find perfect squares, right? Reduce it so that you can be in lowest terms. But then do not find a y because we are not looking for complex points of intersection. Does that clarify it for you? Great. So folks, what we are doing now, I'm going to stop the recording.